In this lecture, I want to talk about different forms of interdependence between observations and what it does to our regression models. So we have talked about temporal dependence between observations, where observations that are observed over time for the same unit are not independent observations. So that is all that the time series is about and temporal autocorrelation, which we have extensively discussed. In this video, we're going to look at other types of interdependence. So let's first start with looking at dyadic data, which I'm not going to talk about much, but which is very common, especially in international relations. And it's sort of an initial step towards what the rest of this video is about. So in dyadic data, instead of having individual observations, we have observations of pairs of units. So this is typical in, for example, analyzing trade or conflict. We can look at pairs of countries and then look at the amount of trade between them, or whether or not they fight a war between them, and so forth. So this is a type of panel data, but instead of having n observations, you have n squared observations because of each of the pairs. Or maybe not directional and half of that. So each row would have a particular dyad, probably in a particular year, and then information on either the pair, the amount of trade between them, whether they are members of the same international organization, whether they're neighbors or not, and so forth. And then maybe also data on each of the units, whether they are democracies or not, and so forth. So here we often apply relatively normal panel data models, except that we assume that there is clustering in the standard errors based on each of the two countries. So we assume that the amount of error variation of all relations that Germany has with other countries, for example, will be clustered, will be related to each other. And all the external shocks that happen to any other country that has relations with Germany, that they will have some common shocks. So we assume that there is clustering in the errors, that the errors are not fully independent, depending on each of those individual countries. But aside from that, we treat it pretty much like normal panel data. Now you could argue that when we look at dyadic data, we might be overlooking important interdependencies that, for example, would be visible when we would look at triadic data. So we might assume that the trade between Germany and the UK might be influenced by both of their connections with the Netherlands. So the amount of trade between the Netherlands and Germany and the Netherlands and UK might affect the amount of trade that is there between Germany and UK. And if we look at only dyadic data, we're going to overlook these kinds of interdependencies. So we might want to look at triadic data. And in triadic data, there are many different possible patterns of connections. Here's an overview of the kind of configurations that might be there if you have a directional flow. So the amount, if we look at ties between these different observations, not as just whether they're connected or not, say member of the same organization, but they are directed, they are flows. There's the amount of trade that goes from one country to another country. So if we start to worry about triadic data, then soon enough you also need to look at higher order interdependencies. And this is where network data comes in. So this graph just a little bit about the terminology in network data, and then I'll explain how we then deal with this in regression later in the next videos. Yeah, so the observations tend to be called nodes or vertices. So we can think of them as countries, for example. In political science data, network data, it is often about countries. And the individual observations are the nodes or vertices. The individual countries are nodes or vertices. We also might look at a social network. For example, a network between MPs and how often they retweet each other. Then we can think of these MPs as the nodes or vertices and the ties as the amount of retweeting that one does for the other. So these ties are called ties or edges or arcs. These are the connections between observations. So to stick with the retweeting example, we could have a directed network where we look at how often MP number 1 retweets MP number 2, but also how often MP number 2 retweets MP number 1, and these are not the same numbers. So that's a directed network. We could also have an undirected network where we simply look at whether two MPs have a tie or not, say whether they're from the same country or from the same school. In that case, it is symmetric, that if one has a tie with 2, then 2 must also have a tie with 1. We can't talk about the directions like with the tweets. So a network can be directed or undirected, And when we talk about the different units that are connected to each other, we refer to them as nodes or vertices. And when we talk about the actual connections between those nodes or vertices, we talk about edges or ties. So we can now have all kinds of high-level interactions. There is the temporal correlation, that the values at previous time periods will affect values at current time periods. There is the network autocorrelation, where neighbors will affect each other. And there is these higher level interdependencies, where the ties between two units might be affected by the ties of those two units with other units. For example, the example that I gave about Germany, the UK, and the Netherlands. And when we take these kind of interdependencies into account, and the dependent variable, the thing we are trying to explain, is related to the ties, we try to explain whether two countries fight a war, whether they end up in the same international organization, we try to predict the amount of flow between them and so forth. Then we're talking about network statistics. When we try to take these same higher order interdependencies into account, but we are trying to explain some feature of the nodes, for example, we try to see whether democracies are more likely to be surrounded by other democracies, or we try to see whether a particular policy spreads across a network, then we're talking about spatioeconometrics.